Hi, this is Beale, and I'm here at KringleCon, and I want to give you a quick introduction to attacking a Kubernetes cluster. In Guardians, we do a ton of red teaming, and we get to do some defense too, and we do quite a bit of attack. And lately, we've been attacking a lot of Kubernetes clusters, and so I want to tell you how to do that. Look for some of my other talks for a longer introduction or for the next kind of intermediate episode. So let's see. This is my bio slide. So you're looking at the real life picture of me, and of course, a bio is a sea of text, and so I have another kind of bio slide. So if you were to pause here and look, every single one of these images has something to do with some part of my career over the last 20 years. Without further ado, let's talk Kubernetes. So here's what we're going to talk about. I'm going to tell you what Kubernetes is, just a little bit, because we're in a very short intro here. I'm going to talk to you about how you attack it, and then I'm going to demo a basic attack on a Kubernetes cluster, where our goal is to start from having compromised one program that's running on Kubernetes and turning that into complete control of the cluster and all the machines that it's running on. So when we get into that, I'm going to be doing a demo, and my demo is recorded because the demo gods are they're all descended from Loki, and they are tricky gods, or demons perhaps. So let's start first with what is Kubernetes. So if you've heard of Kubernetes but have no idea what it does, count yourself in the majority of the InfoSec field. Kubernetes is something that's been around for 5 or more years, but it's becoming incredibly popular lately. And basically, to make it really simple, if you're used to the idea that you have a host that runs Docker, or it runs some other way of creating Linux containers on a system, what would happen if you decided you wanted a cluster of machines that were running Docker, and then you wanted to basically organize everything that they were doing, so that you were creating kind of almost a software-defined data center, not just the software-defined network. So think of it, just to make things really simple. If you have a cluster full of machines running Docker, all those machines running Docker, we call them nodes. And Kubernetes is basically going to coordinate multiple nodes. It's going to coordinate that by having a bunch of central infrastructure that runs on one or more masters. So let's just say that runs on a master node, and then there'll be a whole bunch of worker nodes, and all those all the nodes, even the master, are running Docker or some other container or some other kind of container runtime, and they're running something called a kubelet, and the kubelet is there to tie that machine, that node, into the rest of Kubernetes. So Kubernetes, in essence, orchestrates Docker or whatever your container runtime is, and the kubelet, and a kube proxy, but we're not going to get into that. And those do the real work. So to take over a cluster would mean violating expectations in any way. So I've got a little slide on just some of the attack steps. These are just some of the kinds of attack steps that you have available in Kubernetes. So one is, and these steps are all taken from the perspective that you've already got remote code execution usually in a container on the cluster. And I'm going to add one more term for us, and that term is pod. So Kubernetes clusters work from the perspective not of containers, but of pods, and each pod has one or more containers in it. So if I say the word containers sometimes and I say the word pods sometimes, think of a pod as having one or more containers. Often, very often, a pod just has one container in it. Look at some of my other talks for finding out why you have multiple containers in a pod and so on. So here are the kinds of things we can do to attack Kubernetes. So once we've landed, and you're going to see some of these in the demo today, once you've landed in a pod, in a container, you might choose to ask the API server, the API server, the component that lives on the master and accepts your commands via REST API. You could ask it to basically do this equivalent of a Docker exec. You can say, hey, I'd like to create a shell in some other container. Would you let me? And if you're allowed, then you'll be running a shell in that other container. Or you can just run a single command. What else can you do? You can launch a container onto the cluster by talking to the API server. You can say, hey, I know I'm in a container, but I'd like to start another container. And maybe that container could have more privilege than the one I'm in. You could abuse, or you could set up what's called a volume mount, where you're basically mounting directories on the node, on that kind of host file system outside of the container, into the container. You can ask the kubelet, that's the thing that's running on the node, talking to Docker, and also talking to the Kubernetes master, to exec a command or a shell in an existing container. So there's kind of multiple attack surfaces. It's not just attacking the central part. You can interact with and thus attack the Docker daemon on the host, and then you can interact with, say, the internal or external networks that are available. So you're going to see some of this. We're going to get into a demo, and I've got, like I said, I pre-recorded my demo, and I'll just kind of show you what a Kubernetes cluster compromise looks like from the perspective of the person doing the compromise. So this cluster is the cluster that you're seeing is one that I'm going to be releasing as soon as an open source project. It's called Bust a Kube, like Kubernetes Bust a Kube. So here we are. So you'll be able to kind of repeat my attack later on. So we've got I've started this off in Metasploit. I've kind of fast forwarded, as it were, and we are inside of a container that's running in Kubernetes. We've got a shell. So you've seen I just typed pwd, and it says you're in var-dub HTML. So we got this shell because we found a remote code execution vulnerability in a web app. So now what do we do? Well, I happen to know we're in Kubernetes. But here's a nice little way of checking, and also of remembering the directory the service accounts are kept in. This mount and grep that for Kubernetes, and this directory that you see, run secrets Kubernetes IO service account. This is where the service account that the pod is running under will be mounted into the pod, unless the cluster is one where it's been configured not to, which is not very common yet. So what I'm going to do is I've uploaded, using the interpreter before the start of this demo, I've uploaded a copy of kubectl, and kubectl, or kube control is how it's normally pronounced, is a binary that that basically issues those API requests, those REST API requests against the Kubernetes API server. I'll use kubectl, and I'll tell it, get the token, get your security token for the service account from that magic service account directory in the token file. Just cat it out, and you'll find the certificate authorities root cert in the same directory in the CA cert file, and I have to tell it where the server is, and I can get this out of an environment variable, but I have to tell it where the master API server is to be found, and I do that. And that namespace file tells me I'm in the default namespace if I were to look at it, but I'm not going to look at it in the interest of time. So this is this whole var-dub. Normally you just type kubectl, but when you've hacked your way into a cluster, there probably won't be a kubectl in there, much less a configuration setup. So we're just passing on the command line. You'll do kubectl and then some commands. And so you're going to see me copy and paste this long string and then whatever command I'd use. So the first one I choose is get pods, and this shows me all the containers that are running on the system in the current namespace, which is kind of where the app has been deployed. So this is the guest book that came with that's in the Kubernetes example docs. It happens to have a funny little vulnerability that doesn't lead to remote code execution, and I've added another vuln that you can tie together with it. So I've got 3 front-end pods, and I've got a Redis master and a pair of Redis slaves. So there's a Redis database being used, and there's a front-end web server that I got into. I pass along that get pods minus output wide, and I get to find out what nodes they're all running on. So Kubernetes will go and distribute things as much as it can onto multiple computers, because part of the purpose of Kubernetes is to handle machines failing and having the applications or programs they were running still continue running and lose as little compute time as possible. So what I'm trying to do, the very first thing I'm trying to do is I'm saying, okay, I ran get pods, and now I've created this thing called attack pod. And this attack pod YAML is a YAML file that says, here's a description of, in essence, a container, and I'd like this to run on the Kubernetes pod. and I'm trying to stage a pod into the cluster, and I get this error that says, no, sorry, your service account, the service account front end, isn't allowed to create pods in this namespace, isn't allowed to create pods. So I can't stage pods. Well, let me see what else I might be able to do. Let's say I try to see if I can get to another service account. If I can move laterally to another pod, it might have a service account that can do things I want. So I'm going to use another kubectl command, a kube control. I'm going to use kube auth module, and then say, can I exec into pods? Can I run programs in other pods? And it says, yes, you can. Oh, that's my favorite word here. So that's great. That means I can move laterally. So I'm going to go and run that same kind of thing, and I'll use the same kind of Docker syntax I use and do this docker exec it. And think of it like interactive terminal. It's not quite that, but it's a great way of, it's the way I keep track of it. And I'm going to say, I'm going to go into the Redis master, and I want to run an interactive bash shell. If there's a bash shell in there, I would like to run it. And this is what I've done. I'm in that now. I type ID, it says your root. And I type host name, and it says your new host name is Redis master. So I'm now in a different container. And actually, if we were looking, we'd also find I'm not just in a different container, I'm on a different machine. I've hopped machines in here. So now from that container, I'm going to pull down a copy of my interpreter reverse shell, write it into this file called Mrs. bin from interpreter reverse shell bin. And I'll pull down some YAML. I'll pull down that same kind of YAML file. YAML's like yet another markup language. It's a simple markup language, but it turns out in Kubernetes, the bulk of the way you do everything is you describe the state you'd like in YAML, and then you pass that in to the API server, and it says, sure, I'll do that for you. So I'm pulling down an attack pod YAML file that I already made, pulling down the interpreter. I'm running the interpreter binary, and that's just to give myself kind of the opportunity for a better shell or for a better remote access Trojan. So I'm going to background this channel, the front end one where I hopped from, and I'm now going to switch over back into my Metasploit console, and I'm going to catch the next session. And the next session is this Redis pod. So I'll interact with it. I'll upload a copy of kubectl to it. I've cut out some of the time there. Type shell so that I can back in a shell. And now I'm going to take bash -i to get a little more friendly shell. And I've got this colorization that is so much a pain in the butt. But I'm going to go to my Kali system, and I'm going to grab my PS1 variable, which is kind of what defines what this prompt looks like. And I'm going to set it. I'm going to set the one in the host I've compromised to the same one that I have here, so that just things will look a little bit nicer. I couldn't clear my screen, so I go and set my term variable to a VT100. Anybody old school enough to know what that is, I salute you. Get that service account directory. Just find out what it is. I'm going to copy it. And I'm now going to create a more friendly kubectl file, kubectl command line, where I don't have to keep copying and pasting. So the first thing I do is I create a token variable that just has the contents of that token file, of this service account token, of this service account's token file. And I'm going to create a quick little alias. I'll alias kubectl to the full path where I uploaded kubectl, and then all of those other arguments, like the token equals, and it'll be $token, and you can find the certificate authority in this file path, and so on. So I'm setting that up so that I can run, so that I can do just like the proper owners of this cluster, as opposed to the new owner, which will be me. They just get to run kubectl commands, and they're much more elegant. They look much more elegant, so we're going to do that too with a nice little alias. So kubectl get pods -o wide, and now I've got that same list that I had earlier. I do a get pods real quick just to practice and just to make sure that I've got the thing working. But now what I'm going to do is I'm going to say kubectl apply and give it a YAML file and say make this so. Right, so this is how you give Kubernetes an order. You give it a YAML file that describes this pod you'd like to be running on the cluster, and here's this YAML file. And if you look over this, if you pause your video, you can find it's got a name, it's got labels and annotations, which we're not using here. It's got an image, and I chose that image by doing a kubectl get pods, getting a list of the pods, finding the Redis pod, and asking what image it used. That way, the Docker hosts wouldn't have to pull down a new image from the internet. And these other parts I'm highlighting are basically, this is a volume mount. I can say I want this container that I'm asking to run on the cluster to not just be running and to use the Redis image as a base, but I'd like it also to have a volume mount. It's going to mount the hosts, so this host path, it's going to mount the host, the nodes, root path, and it's going to, which is slash, and it's going to mount that into the pod, into the container as slash root. So it's going to mount that into the container slash root, which is going to give me control over the host file system that the container is running on. So now I do my get pods O-wide, and I find there's my attack pod. It's running on Kubernetes node 2. So this is a 3-node cluster. There's node 2, node 1, and there's KS master. We're not looking at that right now. So now I'm going to try to run my kubectl exec into that attack pod. I'm going to be root, but even better than being root, I'm also going to have mounted the right path. So I'm going to have mounted the hosts slash, the host's root into slash root. So I cd in slash root, and here's the host. So now I'm going to do another cool little Unix Linux trick. I'm going to do chroot slash root. I'm going to start a shell locked into slash root directory. Inside this shell, slash root is the root. Slash root slash etc will be the etc. So this is basically like kind of making this part of the file system my image of the computer, which is good because that's the overarching, that's the host, that's the node. So I look at the sudoers file and I find there's an admin group and a sudo group. So I grep the sudo group and I see this user called lockthisdown. So let's just change lockthisdown's password. So I'll change lockthisdown's password and I'll set it to lockthisdown. And now I will SSH in to the node from my own Kali system to node 2 where I've changed lockthisdown's password. And I'm in. And if I were to sudo su, what would happen? I'm root on the node. Okay, that part, I cut that video a little tight. That went by in a hurry, but that's where it was. I'm root on the node. So now the thing is, how do I do that scalably? A Kubernetes cluster doesn't usually have just 2, 3 nodes. It has like hundreds or thousands, or maybe in Google's case, millions. And so what I want to do is actually say, how do I scalably take over every node in the cluster? And for that, I create something called a daemon set. It's similar to defining a pod, but this daemon set defines a pod that you'd like to run on every node in the cluster. It's usually for like a logging daemon or a security daemon or whatever, software or what have you. Something you need to run everywhere. And this is the same thing. This attack root is the name I'm calling of this container. And I'm using that same Redis image. And remember, I picked the Redis image because it was the same thing that the Redis master was using. And I'm also doing that volume mount. I'm saying I'm going to have a volume mount. It's going to be called host root. It's going to mount host root into slash root. And then if I look at the volume host root, it is the node host path slash. So I'm going to say, I'd like to do that across everything. So now let's take our, so that daemon set, okay, clearly in my video, I'm not going to go over that all again. So, so here we go. I'm going to do kubectl apply and see if I'm able to apply a daemon set. And I am. Okay, so the cool thing was, the difference was the front end pod, its service account couldn't add pods to the cluster, but the Redis master's pod, Redis master pod service account, it could. And so I've just added, I just added the one pod to take over node 2, but now I'm adding a daemon set. I'm adding an identical set of pods, one for everything in the cluster. And it's called attack daemon set. And I may have to wait a minute for it to load, but once I do wait for it to load, I can run this kubectl get pods -o wide. That tells me which nodes each thing is on. And I grep for attack, and you'll see this attack daemon set. I've got 3 pods. Each one's called attack daemon set, and then a random string. And each one of them is running on a different node. So I've got one running on the master. I've got one running on node 1 and one running on node 2. So now let's do a little bit of, I've done a little bit of shell scripting. I've written a for loop here. So I say for pod in, and that what's it going to be in? What's the set I'm going to loop over? I'm going to do kube control get pods, grep that for attack daemon set, awk it to get the first column. And what I'll do now is that gives me a list of each of those attack daemon set pods. And I'm going to do a for loop over them. And in my for loop, I'm going to do kubectl exec -it into the specific pod, into the pod that I'm looping over. And then I'll do cat root etc hostname. So so that I know where I am. I'll cat root etc shadow. And then I'll take the output of all of that and I'm going to grep out for a pattern, and that pattern will be helpful. So let's take a look at how that looks. There's a little bit more going on, but when I'm done, this is what I end up with. I get the host name of each of these nodes and the root hash and the lock this down hash for each node. Now, for me, this was to demonstrate that I had full read access to every one of these, and I can get their passwords. Now, I also have full write, and so I'll demonstrate that real quick. And this is kind of one of the simplest attacks on a Kubernetes cluster. I've put in some lateral movement. I've put in starting a pod, but I have much more involved attacks on Kubernetes clusters. And watch some of my other talks. My name's Beale. Find some of my other talks, and you'll find some more involved things, and I'll start to release some good capture the flags on it. So I'm doing a quick loop, and I'm going to go and basically touch the file /root/owned on each of those hosts. And what happens as a result is if I go and look at one of those hosts, so I've SSH'd in the master. If I go and look for an owned file, there it is. So this means I've compromised every single node along with the master. So that's basically the long and short of it. Let's look back at what our attack steps were. So I exec a command into a container via the API server. We did that. We launched a container on the clusters. We used a volume mount to steal or modify data on the host itself. We didn't ask a kubelet to do anything. We didn't interact with the Docker daemon or internal or external networks. So those are clearly some of the other things we have. And there are a bunch of other attacks. One of the most fun ones, honestly, is to see if your cluster is running on AWS or is running on GCP or on Azure, and see if you can reach the metadata server and basically get a copy of your service account token that the whole cluster is running under. Because then you have not just the hosts, but you actually have the account, which means you basically have kind of the data center, or at least whatever your account can do in the data center. So anyway, that's all I have to tell you about. I do want to tell you that InGuardians I'm one of the co-founders of InGuardians, and we've been around for about 15 years now, hacking and defending, and we'd love to hear from you. But most of all right now, I just want to tell you we have an awesome executive briefing newsletter. Comes out once a week, and it's basically one topic in security that's come up, usually in the news, and what we think you should do if that thing's applicable to you, or if it's applicable to somebody you know. We won't spam you. The most you'll ever get from subscribing to this to this mailing list is one newsletter. So anyway, that's me, and I hope you'll maybe find me around KringleCon. I may be in here now and then. So yeah, thank you very much.